Okay, on Wednesday after the quiz, you should have looked at inequalities, and please let me know if I'm wrong, but you have seen inequalities in the past in a class, correct?
Yes.
Okay, good. So hopefully in 6th grade, but I think also in 5th grade, you may have seen them too. Obviously not as like complicated as we're gonna get in here, but at least like seeing them on a graph or seeing them represented. So here's a number line. And this inequality is graphed, and we know it's an inequality because there's a circle around a number and it's shaded. It's shaded in this case to the right. It could be shaded to the left. So I want you to notice first the circle. What did I say? 38, Selena. The circle is an open circle. And there's two options, obviously. We're either going to have an open circle or a closed circle. In this case, this circle's open, so it's not filled in. And that means that the number that it's around is not part of our answer. So if our circle is open, that means that whatever we're talking about, in this case 2, is not part of the answer. All the numbers that are shaded are part of it, but not 2. So the numbers that are graphed in this number line are all the numbers greater than 2. Those are the numbers that are graphed here, the numbers greater than 2. So can we list all the numbers that are graphed? Why not? There's more specifically than too many. How many are there? There's an infinite amount of numbers. So yes, I know we're looking here, graphed 3, 4, and 5. But that arrow indicates that it keeps going, right? 6, 7, 8, 9, 10, and so on. But also, even just on this number line, there's an infinite amount of numbers, because in between 2 and 3 and 3 and 4 and 4 and 5, there are decimals. 2.1, 2.2, 2.3, 2.4, 2.5. We can even get more specific. 2.01, 2.001, 2.0001, 2.000001. There's going to be an infinite amount of numbers. You could start listing them, but we'd be sitting here for a while. So go for it. Start listing all of them. I'm kidding. Don't do that. I'm kidding. Don't do that. Okay. Yeah, don't do that. So the answer is no. We couldn't sit here and list them unless we sat here for the rest of our lives. And I love you guys, but I don't want to sit here for the rest of my life. And I'm sure you guys don't either. Okay. So the reason why we can't is because there are infinite numbers. But what we can do instead of like listing all of the answers is we can write an inequality. So for this inequality, the answers are represented by X. We're going to use any variable. I'm just going to be consistent using X. X is greater than 2. So my answer, my solution here is all the numbers that are bigger than 2. And that could represent an infinite amount. Now this next part is going to look a little weird because it's just different. It's a different kind of notation than you've ever seen before. It's called set notation. And to be honest, it's more something you'll see in like a college math class, but important to recognize. So when we have an inequality or any sort of answer, we can represent it using a set notation. So set notations include braces. Y'all know what braces are? They're like this little thing. I'm not the best at drawing them, but that's what they look like. On your keyboard, it's like next to the P. If you hit shift, that bracket, it's like right above that thing. So we open our brace and we write our variable. So in this case, our variable is X. And then you are going to draw a vertical line. So what that's saying is I have a variable, and now I'm going to give that variable a rule. That variable X has to be bigger than 2. And that is the end of that notation. So since it's the end, you want to like close it out, just like you do parentheses. In this case, we're going to do braces. Yeah, Lauren, those are the two that you'd use. So again, what that's saying is We have a variable, but the rule for that variable is that it must be greater than 2. So that's set notation. Again, a little different, but not hard, not difficult to write. All right, let's look at another graph. So besides it being around a different number, what's different about this graph than the yeah, the circle's closed, right? So we have a closed dot or circle. So that means that whatever number that's around is a part of our solution. So if we were to write the answers or the inequality here, we want to get a variable. So we'll use X. And instead of just being greater than, it's greater than or equal to. And we can show that by drawing that line under our greater than symbol. In this case, it's greater than or equal to 10 because that's where our circle's around. The solution set that's represented by this graph. So again, we want to write our braces. So we have our braces and we have, oh, see, I end up just drawing squiggles because I'm not very good at drawing them, especially the right one. I can draw the left one pretty good, but I can't draw the right one. So we have our variable X and we want to give it a rule. X has to be greater than or equal to 10. And then the last question before we start doing a little bit of solving is why is or equal to included? Well, we know that from the graph because the circle is closed. So that indicates that it's going to be or equal to, whether it's greater than or less than. Just like we had properties of equality, so subtraction, addition, multiplication, and division, all of those things still apply when we're talking about inequalities. So X is greater than 5. So give me a number, Lauren, because it's also equal to the, wait, which line? The vertical line, this one? I want to make sure that I'm talking about the right line. Yeah, that one. That's just part of the notation. I don't have a good answer. It's just mathematical notation to describe that answer. Someone give me a number bigger than 5. 6. Oh, y'all are so creative. 6 is bigger than 5. So I have a question. Is 6 plus 1 greater than 5 plus 1? How do you know? No. 6 plus 1 is 7. 5 plus 1 is 6. 7 is greater than 6. Yeah. So you'll see that our rules still are true. We could add 1 to both sides and I still get the same answer. No matter what, I can subtract 1 from both sides and I still get the same answer. So let's look at one we actually need to solve. So 2x minus 1 plus 2 is greater than x plus 1. I'll be honest, I'm not quite sure why there's parentheses here because technically we're distributing a 1. It's not really going to change my answer. So I'm going to rewrite this without the parentheses. So think back to equations. We are going to solve this just like we would if it were an equation. The process of solving is no different. We're trying to get the x by itself. So we want to follow all the steps to do that. Does anybody see anything I can do to start this? So again, I want you to think back to when we were solving equations. Henry, what could I do to start?
Add the 2 minus 1.
Okay, I could take the minus 1 plus 2. I could combine those like terms. So let's do this first. So that gives me 2x minus 1 plus 2 would be plus 1 is greater than x plus 1. Trey, did you have a question or were you going to answer? Okay. So now I can't do anything on either side. So this is the decision-making process. I either need to do something with the 2x or the x. It does not matter. I'm going to choose the X because I don't want to get negative numbers. It's your call. So I want to get rid of a positive X. How do I do that? Subtract it. So we want to subtract X from both sides of that equal, or that's not an equal sign, that greater than sign, just like we would if it were an equal sign. So 2x minus x is x plus 1 is greater than 1 is all that is left over on the right-hand side. So x is being added by 1. We want to do the opposite, which would be to subtract 1. So x is going to be greater than 0 would be our answer. X would be greater than 0. Yes.
Why can't you subtract the plus 1 before you divide it by x?
Why couldn't I subtract the plus 1? You could do that. It's not wrong.
Oh.
I'll tell you that I tend to not have people try and avoid that. So Henry's question was when I was here, why couldn't I just subtract the 1? Not wrong. So I would end up with 2x is greater than x. So sometimes when people get there, they don't know what to do next. So I usually tend to have people do this first because it ends up looking like a 1 or 2 step inequality or equation, which you're pretty comfortable with solving. Okay, good question though. All right, so let's do one more together and then I'm gonna have you practice a few. So 4 plus x is less than 5 is greater than or equal to 10. So again, unclear why there's parentheses here because they don't really matter. So I'm going to get rid of them. So I see a 4 and a minus 5 that I could combine. So let's go ahead and combine those to get x. 4 minus 5 is minus 1 is less than or equal to 10. 10 is, or x is being subtracted by 1. So we want to do the opposite, which would be to add 1. So x is going to be greater than or equal to 11. And I did ask you to write it in set notation. So let's try that. So we want to use our braces. And I have an x, and my rule is that x has to be greater than or equal to 11. Now let's talk about graphing. Please do not always start your number line at 0. Why would I tell you that? No, because sometimes we're going to have inequalities that say like x is greater than 6,000. And if you start your number line at 0, how many numbers are you going to have to write? A lot. So when you graph, I encourage you to write whatever number we're circling in the middle. So in this case, my middle number is going to be 11. And then I would write 2 numbers on either side. So a number less than 11 would be 10. A number greater than 11 would be 12. So what kind of circle am I going to put on the 11? A closed circle. Please emphasize that closed circle. Like make sure that I realize that it is all the way closed and not open. Which direction am I going to shade? To the right. How do you know? Okay. So I have a question, and you don't need to call any teacher out if they taught you this. Did anybody learn that you shade whatever direction that's pointing in? If you did, you don't have to tell me who taught you that. I just want to know. Okay. I want you to unlearn that, and let me explain why. Although in this case, true. And what I'm talking about is you see how this is like pointing in the right direction. So you shade to the right. Okay. What if this answer was written like this? Those are the same. These two things are the exact same. So if you're following this trick, then which way would you have shaded? To the left, which is incorrect. Okay. I'm not a big fan of math tricks. I'll just be honest, because they don't necessarily work every time. I hate PEMDAS. I hate KFC, KCC, all that. I don't like this. I don't like using the word alligator mouth. That's not an alligator mouth. Whoever told you it was an alligator mouth, go tell them it's not one, okay? Because I'm sure somebody did out there someday, previously, okay? It's an inequality symbol, all right? So again, not that that's wrong, but I hope you notice that it's not going to work for you consistently. So I don't want you to kind of rely on that trick to make it easier. Okay, I'll step off my soapbox now. So I want you to try 2 and 3, but before you do, what's deposit mean? Which is what operation? Adding. Okay, does anybody know what the opposite is? If you withdraw, yeah. So just making sure that in number 3, when it's talk about it, depositing $27, that's adding money. Okay, if it wanted me to subtract money, I would be withdrawing, and that would indicate subtraction. All right, number 2, again, unclear why there's parentheses. They don't really matter. So I'm just going to solve them without those parentheses. So 4x plus 8 is less than, so we can combine 1 and minus 5. 1 minus 5 is minus 4. Then we have to make a decision. And this is kind of where I'm giving you the suggestion. You don't have to listen to me, but I would move over a variable. In this case, I would do the opposite of a positive 2x and take away 2x to get 2x plus 8 is less than negative 4. Because remember, we got to include that minus there. And then it looks like a 2-step inequality. So we want to subtract 8 from both sides to get 2x is less than negative 4 minus 8 is negative 12. And then we want to divide both sides by 2. Thank you. To get x is less than negative 6. So negative 6 was the answer there. You want to make your number line. You want an open circle around negative 6 and shade the smaller numbers, which are to the left. And then if you were wanting to write your set notation, it would look like that. Hopefully your braces are better than mine. Number 3, some people are confused, so let's talk about this. We don't know how much money he started with, so we're going to use that as our variable. So I'm going to call that x. But I do know he deposited $27. So that means he added $27. And I know that he ended with $234 at least, or no, what does it say? It doesn't say at least, over $234. So if I want more than 234, then my inequality symbol should be that way. I know that I want more than 234. So then I want to subtract 27 to get x is greater than 234 minus 27 would be 207. So my question is, what's the least amount of money he could have? Not 207, because it can't be equal to. Nope. 207 and 1 cent. $207.01. We can't say 0.00000000 and so on 1 because yeah, we're talking about money. Money stops at the hundredths place in America. We have pennies for some reason. I don't know why, but we do. So we stop at the hundredths place. I don't think we should have pennies. I think everything should be rounded to the dollar, but that's just me. Coins are stupid. Coins are stupid. I think dollar should be like the least amount of. We also have a coin shortage right now.
But then if you wanted to buy something, it was $29.99.
No, that means everything would just be rounded to the dollar.
No, regardless, some people like to buy like really small, like cheap stuff. Like
Maybe they
$1.
shouldn't be buying that cheap stuff, Kale.
Yeah, they should be throwing away their money with that.
Okay, because we have howl out today, I would normally wait to do the second section after lunch, but because we have howl out, and you don't have to agree with me, we're gonna do it now, just so that when you get back from howl out, all you need to work on is your homework. Yeah. Okay. So consider x is greater than 5. So besides 6, let's pick a different number that's greater than 5. Go ahead. Malia, what do you want to pick? She had her hand up. Oh, I can't hear you.
What?
Say again.
What'd you say?
Pick a number greater than 5. Not 6.
1,000.
Oh my God, 1,000. How about 7?
Let's do 1,000.
Let's do 7.
Let's do 10.
How about
7 is greater than 5. I decided 7. Sorry, I'm the dictator in here. I'm not like a mean. I'm not like all the other dictators. I'm a good dictator. Okay. So is 2 times 7 greater than 2 times 5?
Yes.
Yeah, because 2 times 7 is 14. 2 times 5 is 10. Okay. So let's try another one. Let's pick a different number greater than 5 that's not 1,000. 10. So my question is negative 2 times 10 greater than negative 2 times 5? No, you're right. It's not. Negative 20 is not greater than negative 10, and that's a problem. So we need to do something to make this true. We can't change the numbers because we can't change what things multiplied together equal. What could we change about this inequality to make it say something that's true? I heard someone say switch. Luke, was that you mumbling over there? What do you, switch what? Okay, what sign? Thank you, the inequality sign. We're gonna switch it from a greater than to a less than. Does that make it true? It does. Okay, so I want you to notice something. When we multiplied by a positive, it gave me something that was true. When we multiplied by a negative, it gave me something that wasn't true. So we have to make that change. We have to flip that inequality sign when we multiply by a negative or divide. And I want you to think about that. We started with 10 and 5. If we multiply by a positive number, we're making both of those numbers more positive. When we take those two numbers and we multiply them by a negative, we're making both of them more negative. So 10 is now going to the negative side of our number line, and it's getting farther away from 0 than 5 times that negative number would be. So for us to be able to answer this correctly, we would have to flip over that inequality symbol. So whenever you are multiplying or dividing by a negative, you must flip over that symbol. So we're just going to kind of make a blanket rule here. So anytime we have two things, whatever they may be, and we multiply by a positive, that greater than is going to stay a greater than. If we're starting with a less than and we are multiplying by a positive, we are going to keep it as a less than. So here's where we're going to change the sign. When we are multiplying by a negative and we started with a greater than, it's going to change to a less than. If we started with a less than and we multiply by a negative, we're going to change that less than to a greater than. right, so let's try a few of these. The first one says negative 9y plus 4 is less than negative 7y minus 2. Again, there's multiple different options here, but I want you to first add 7y to both sides. You could add 9y to both sides. You could subtract 4 from both sides. You could add 2 to both sides. But just trust me that this is going to make your life a little bit easier. So negative 9y plus 2y or plus 7y is negative 2y plus 4 is less than, and then negative 2 is what's remaining on the right-hand side. So y is being multiplied by negative 2 and added by 4. So we want to do the opposite. We want to subtract 4. And that would give us negative 2y is less than negative 2 minus 4 is negative 6. And then we want to divide both sides by negative 2. So that would give us our y. And we divided by a negative. So that means my less than symbol is going to become a greater than. And negative 6 divided by negative 2 is going to be 3. So again, because that 2 was a negative, we need to flip that symbol over to the being a greater than. Yeah, Amelia.
So even though the answer would be a positive, you still have to do it?
Yes, because this number that we are applying to it is negative, we change the sign. Okay, good question. So if we were to graph that, we would put a circle around 3. What kind of circle? An open circle, because we don't have an equal to. And is my y bigger than 3 or smaller? Bigger, and my bigger numbers are to the right. And then if I wanted to write that in set notation, I would have y as long as y is greater than 3 would be my set notation. All right, we're going to try one more together, and then I'm going to have you work on 2 on your own. So let's look at number 2. Sorry, I meant letter B. That's what I meant to say. M divided by 3 plus 8 is less than or equal to 9. So M is being divided by 3 and added by 8. So we want to do the opposite. So the opposite of plus 8 would be minus 8. As Selena, it only applies to multiplication and division, not addition and subtraction. So only if we're multiplying and dividing by a negative. So that would give us M over 3 is less than or equal to 9 minus 8 is 1. M is being divided by 3, so we want to multiply by 3. Do we change the sign? No. Why not, Luke? Because what's positive? Which number? 9? 3? You mean 3? That's what you meant, right? Okay. Why it doesn't matter. I don't care about the 9 anymore. It's gone. I care about the 3. The 3 is positive, so I'm not going to flip the sign, but 1 times 3 is 3. So my answer would be M is less than or equal to 3. Quickly, I'll graph it. We want to circle around 3. What kind of circle? A closed circle, and we know that because we have an equal to, and we want to shade which direction? To the left, because M is smaller than 3. Okay, before you do number 3, I'm going to have you flip the page and jump to number 3. I am not going to answer any questions about letter B. I want you to do A and B. I want you to show me your answer to A, but I want you to do B, but I do not want you to ask any questions, and I'm not going to answer them even if you ask them. On letter A, though, please first distribute that 6 before you do anything else. Please distribute that 6 before you do anything else. -6, I mean, sorry, -6. Okay, on letter A, distribute the -6 to get -6x plus 30 is greater than 42. And then subtract 30 from both sides to get -6x is greater than 12. A few people are still having a little issue with this. So since the number is a coefficient, that means multiplication. So the opposite of multiply would be divide by -6. And that would mean we would need to flip the symbol because it is a negative that we're dividing by. 12 divided by -6 is -2. And then it asks you to graph. So we would have an open circle around -2, and we would shade everything to the left. And then for set notation, we have x as long as x is less than -2. Okay, let's discuss letter B. So almost everybody I looked at got to the same place, which is great. So I would distribute the 4 and the 2 to get 4x plus 12 is greater than or equal to 4x minus 4. So do you want to subtract 4x or 4x? Okay. So that would leave us with 12 is greater than or equal to -4. So I want you to think back to equations. If we ended up with something like this, what would we call that? No solution, because 12 does not equal -4. If we ended up with something like this, what would that be called? Infinite solution, because 3 is equal to 3. So I want you to ask yourself, is 12 greater than or equal to -4? Yes, it is. And there's no more variables left. So it's going to be one of these answers. And because it gives us something that's true, 12 is greater than or equal to -4, it's infinite. Although the numbers are different, I don't care about that. I care that my answer was something that's true. In this case, 12 is greater than or equal to -4. So my answer would be infinite. What would be a case of an inequality that would be no solution? Asa, what would be no solution?
12 is less than -4.
12 is less than -4. That's not true. So since that would not be true, that would be no solution. So I want you to notice the difference there. It's not the fact that the numbers are different. It's the fact that it gives me something that's not true. And that's really important to know. All right, let's look at the beat the test questions real quick. Ulysses, where does that sound familiar? It's the president. Which one?
S. Grant.
Yeah, Ulysses S. Grant. Does anybody know what number? I just know things about presidents. Anybody know what number president he is?
32.
No. Good guess, I guess.
33.
Nope, 18. He was after Lincoln. Well, 2 after Lincoln. Did y'all learn about presidents?
No, not yet.
Oh, okay, never mind. Regardless, Ulysses is on vacation. Has anyone's parent ever rented a car before when you've been out of town? Okay, it costs money. A lot of times they charge you by mile when you rent a car. Like meaning if you drive more miles, you have to pay more money. So there's 2 cases here. Option A, you can pay $25 and 10 cents per mile. Option B, $10 plus 40 cents per mile. Which one would you choose?
Probably the 25, 12.
Why?
If you're driving a long. Option B.
Yeah, keep going.
If you're driving a long distance, the first one, but if you're driving a short distance, the second.
I completely agree. If you're driving a long distance, I would probably choose option A because that means it's cheaper per mile. If I'm driving short distance, then I would probably choose option B. So Ulysses wants to choose option A. So we want to figure out, when would option A be cheaper? How many miles would I have to drive to make option A cheaper? So let's first set up an inequality. So for option A, I have $25 plus 15 cents per mile, M for miles. And I want that to be cheaper. So since it's cheaper, I want to use less than. I want that option to be less than the other option. The other option is $10 plus 40 cents per mile. So 0.40 M. So let's solve for my M to see how many miles I'd have to drive for option A to be a cheaper option. So the first thing I would do is I would subtract 0.15 M from both sides of that equal sign. Again, there's not a wrong answer here. That's just what I'm choosing to do as my first step. You could subtract 40 cents M from both sides. You could subtract 25. You could subtract 10. All of those would be right. So I'm left with 25 is less than 10. Well, what's 0.40 minus 0.15? 40 cents minus 15 cents. 25 cents. And I have a two-step, so I want to first subtract 10. $25 minus 10 would be 15. And I have 0.25 M. M is being multiplied by 0.25, so I want to do the opposite, which would be divide by 0.25. Hence why I asked you to get a calculator today. Maybe you can do that in your head, maybe not. How many? 60. So what that's saying is Ulysses has to drive more than 60 miles to be able to make that true, to make option A be the cheaper option. Okay, last one. Does anybody know what it means when you have a job and you're paid based on commission? Okay, yeah, Sarah. Yeah, exactly. So if anybody knows someone that sells houses, they work on commission because the more houses they sell, what happens? The more money you make. Car salesmen work on commission, so they're encouraged obviously to sell more cars because they get paid based on how many cars that they sell. Miss Simkins doesn't get paid based on commission. I get paid based on, like, I have a fixed salary that I make when I come to my job. But there are some jobs that are sales based, because I would encourage you to be a good salesman, wouldn't it? If you're paid based on how much you sell, it would encourage your workers to be better salesmen. So Stephanie has an option. She can either make a fixed numbered salary of $500, or she could make commission 5% of whatever she sells, plus $200. So we need to decide how much would Stephanie have to sell to choose the commission option. So obviously we want the commission option to be better or more money, right? So we know that for commission, she makes $200 plus 5%. Now we can't use 5%. We have to change that to a decimal. So what would 5% be decimal version? 0. Yeah, don't say 0.5. 0.05 or 0.05, 500 times her sales. Remember, S is going to be for sales. We want that to be bigger than her $500 option, because her $500 doesn't matter her sales. She gets that no matter what in the second option. So let's solve for how much she'd have to sell. So the first thing we would do is subtract 200. So that would give us 0.05. S is greater than 500 minus 200 would be 300. And S is being multiplied by 0.05. So we want to divide by 0.05. So figure out what 300 divided by 0.05 would give us. Again, be careful because I had a few people last period put 0.5, not 0.05. $6,000. So she would have to sell $6,000, more than $6,000, which is letter D, worth of stuff to be able to make the commission option better. Now she's works for an electric authority, unclear what she's selling. I don't know. But like if you were selling cars and all you had to sell was $6,000, hopefully you could do that. Most cars are more than $6,000. If you're selling houses, I hope you could do that. Every house that I can think of, if you buy it, is more than $6,000. I can't think of a house that is less than that. Most houses start at around like $100,000 when you're paying for a house. You could buy a pretty nice box for $6,000. You're right. Huh? Yes, and just put a bed in it. Yeah, go for it.